In this video, we'll be discussing solutions to the 2016 JEE Mains Physics question paper. The questions I discuss, you might have them in a different order in your paper, so I'll repeat the questions before discussing the solution as well. In the first question, we are given that a student measures the time period of a certain number of oscillations 4 times and the value he gets are 90, 91, 92 and 95. And the minimum division is 1 second. What should be the reported mean time? So we can calculate the mean time initially. That's quite easy. 90 plus 91 plus 92 plus 95 by 4. That will come out to be 92. But there's also a spread, and so we need to derive the standard deviation. That is the average of t bar minus t whole squared. So it will be divided by 4, the root of, so let's just write sigma square first. That will be 90 minus 92 whole squared, which gives me 4, 90 minus 92 minus 91 whole squared, which gives me 1, plus 0, plus 95 minus 2 whole squared, which gives me 9. So this turns out to be 3.5, which gives me sigma is approximately 1.8. So we should write the answer as 92 plus minus 1.8, which is one of the options. But the problem is we are given that the minimum division is 1 second. So these last digits 0, 1, 2 and 5, we are not even sure about these digits. Right, this digit could be 2 plus minus 1 based on the calculations we've done. So it doesn't make sense for us to give this digit as well, because even this digit is not at all certain. So the correct answer would be 92 plus minus 2 seconds, which would be option 2. The next question actually has an error, because we are given that only one option is correct in these questions, but in that there are two options which are correct. I'll give you the solution anyway. A, B, C, D. The particle is moving with a constant speed v. This distance is r, this is 45 degrees, and these sides are a. We need to find the angular momentum going from A to B, B to C, C to D and D to A. So going from A to B, we can use the formula mvd, where d is the perpendicular distance of the velocity or the direction of velocity from this axis. So it will be mv times r by root 2. This is the same magnitude in this direction, and this is also the magnitude of angular momentum in this direction, because this distance is also d, which is r by root 2. So A to B and D to A both have the same angular momentum magnitude, and they both have the same direction as well, because this is the direction of r and angular momentum is defined as r cross p or r cross mv. If this is r, this is v, the right hand thumb rule gives us going into the plane angular momentum, and the same is true for this case. This is r and this is v, so r cross v again will give you your thumb going inside the plane. So this is the angular momentum, and this cross will be minus k cap, because if this is x, this is y, then coming towards you will be z. So this is A to B and D to A. What is it for B to C and C to A? The direction is again the same. In this time it's coming out of the plane, because this is r, this is p, so r cross p will come out of the plane. The same for this, and this distance is d and this is a, so we'll get d plus a. So the angular momentum for B to C and C to D will be mv times r by root 2 plus a, and it will be k cap. From that you can see that the first option is true. A to B, it is indeed minus mv r by root 2 k cap. The second option is false, because it is not r by root 2 minus a, it is r by root 2 plus a. The third option is true, and the fourth option is false as well, because it is not k cap, it should be minus k cap. And we are asked in the question which of the following statements are false. So we should have only one option which is the answer, but there are actually two of them which are the answer. Right. So this is an error, you should probably get marks for this question. In the next question, we are given an object is let go from the point P. This is Q, this is R. This is all a rough floor, and it comes to rest at R. and it is dropped from rest at P. This is H is equal to 2 and this is 30. And we are given an extra thing. At this point Q, half of the energy has been lost. So at this point the energy will be mgh, which I can write as G will be 10, so it will be 20 m. So at this point potential energy is 20. At this point potential energy is 0 and we've lost half the energy. So kinetic energy at this point will be 10 m, and at this point kinetic energy will be 0. So the work done by the friction between P to Q will be 20 m minus 10 m, which is 10 m. And that will be mu mg cos theta L, where L is this distance. So it comes out to be mu into m into 10 into cos 30, which is root 3 by 2 into this distance. Now if this is 2, this is 4, because 4 sin 30 is 2 into 4. And we know this is equal to 10 m. So what does that give us? Mu is equal to 1 by 2 root 3. And we can calculate this distance as well, because if the energy here is 10 m and here is 0 and the gravitational energy is the same in both cases, then the kinetic energy here is 0. So all the kinetic energy here should be lost by the friction. So again mu mg, there is no cos theta now because we are horizontal, into qr should be equal to 10 m again. And g is 10, so mg and 10 m cancel. We get qr is 1 by mu, which means qr is equal to 2 root 3. This value is approximately 0.29 and this is approximately 3.5, which gives me the answer as option 3. A person is trying to lose weight by burning fat, lifts a mass of 10 kg to a height of 1 meter 1000 times. So the work done will be 1000 times the work done when he lifts it once, which will be mgh. So 10 kg into g, which is 10, into h, which is 1. So it's 10 to the power 5. This is the work done when he takes the object up. When it's coming down, there is no negative work done because we are given that the energy is dissipated every time the mass is lowered. So this is the energy. Let's say the amount of fat burned is m, then the energy given will be m into 3.8 into 10 to the power 7 into 1 by 5, because only 20% of it is converted. This should be equal to 10 to the power 5, which gives me m is equal to 5 by 3.8 into 10 to the power 2, or 380, which comes out to be approximately 12.9 into 10 to the power minus 3. So the answer to this would be option 4. In the next case, we are given two rails which are not parallel to each other, CD, AB, and there is a roller which moves on these rails. And we are asked, in which direction does this roller turn? So it's actually easier if we think of a slightly different problem first. Let's say they are not placed at equal distances from the center. Let's say the situation is something like this. Right, so this is not at the center of these two lines. In this case, when this roller moves an angle theta in this direction, obviously the roller is a rigid body, so about this axis, the whole roller will rotate by an angle theta. Now this point is, if this distance we call it, let's say d1, this point is at a distance d1 from the rail. So the amount of distance this point will move on the rail, because there is no slipping, will be theta d1. And similarly this will move theta d2. But in this case d2 is much smaller than d1. Right. So in the next instant, though the right roller will be ahead by a certain amount, the left roller will be somewhere here. I haven't drawn the figure properly. The left roller after a little while will be somewhere here, but the right roller will have gone like this. So essentially it will have turned towards the left. This is sort of similar to when your car is turning towards the left. When your car is turning towards the left, the distance covered by this wheel is more than the distance covered by this wheel. Similarly, if this d1 is greater than this d, then the distance covered here will be more than here, so it will move towards the left. And in this case, even though initially they both have the same distance, as AB is tilted, as this point moves forward, this distance keeps on decreasing. So this situation is sort of like an extreme case of this situation. So in this case also, the roller will turn left because the distance covered on CD will be greater than the distance covered on the rail AB. So the answer to this will be option 1. Let's look at the next problem. We are given a satellite is moving in a circular orbit at a height h from the Earth's surface. So the radius of the circular orbit is r plus h. And the equation we'll get is, so the equation for this satellite will be mv squared by r plus h is equal to gmm whole square, which gives me v is equal to root gm, this is small m by the way, r plus h. And the minimum increase in velocity so that it escapes from the Earth's gravitational field. We know what the escape velocity is, that is root 2gm by r, or in this case root 2gm by r plus h, because the satellite is at a distance of r plus h from the Earth's center. This is r, this is h, and it is moving like this, right? So all we need to do is calculate the difference between these two, root 2gm by r plus h minus root gm by r plus h, which basically gives us root gm by r plus h into root 2 minus 1. Right, this is the final answer. But now we are given a couple of things. One, that h is much smaller than r, so we can just take this to be root gm by r. And the other, we already know that gmm by r squared is equal to mg. Mm cancels, and we know this is the formula for g. That means gm by r can be written as small g into r. So our answer will be small g into r times root 2 minus 1, which gives us option 4. In the next case, we are given a pendulum whose time period changes. We know the time period is root L by g. From that we can derive the equation, because there is a power of half here. We can get delta t by t. The fractional change in time over a certain time period is given as half of alpha delta L. Sorry, half of delta theta. We are talking about temperature, right? L will change with theta and the fractional change will be alpha delta theta. So the fractional change for t will be half of that, because there is a power half. I'm sure you derived this equation rigorously in your classes. So this gives me the first clock loses 12 seconds. If it's losing some time, that means the final value for the number of seconds will be smaller by 12 seconds. That means each interval will have an increased time period. Right, when you lose some time in a clock, that means the time period has increased. So what we can get is 12 by t, which is the total number of seconds in one day. I'll just leave it as it is for now. This is half into alpha into, now delta theta. We don't know what the initial temperature was. We know the final is 40. So we'll just assume 40 minus t, where t was the initial one. We know that the temperature has to have increased because the time period increased, which means the length must have increased. Similarly, in the second case, we'll have 4 by t is equal to half into alpha into, now we'll have t minus 20. Right, because now we are decreasing the temperature, which causes the time period to decrease, which causes the number of seconds to be greater, because the number of intervals will be greater. Right, you can just divide these straight away and you'll get 3 is equal to 40 minus t by t minus 20. From that you can get t is equal to 25 degrees. Small t, we already know what it is, 3600 into 24, the number of seconds in one day. From that you can calculate alpha, and once you do, the value of alpha will come out to be 1.8 into 10 to the power minus 5. So the answer is option 1, 25 degrees and 1.8 into 10 to the power minus 5. Actually, you did not even need to calculate alpha, just 25 degrees which would have given you the correct option. In the next problem, we are given that the molar heat capacity C is constant. So we know NC/dt, which is dq, is equal to NCV/dt plus P dV. This is the first law of thermodynamics. This gives us C is equal to Cv plus P dV by N dt. Right, so we need to calculate this value first. We are given PV to the power N is constant. Let's say it's a constant K. That means we can calculate V as a function of T. So PV we can write as nRT. So what we'll get is nRT times V to the power N minus 1 is equal to K, because we've already used 1 PV as nRT. This gives me TV to the power N minus 1 is equal to K, or T is equal to K V to the power 1 minus N. Now you can get dt by dv from here. That will be 1 minus N K V to the power minus N. So this is dt by dv. What is pressure? P is equal to K V to the power minus N from this equation, which is this. So what we get is dt by dv is equal to P times 1 minus N. Hang on, I'm missing a factor of R here. Oh yeah, we forgot about NR. Right, this is by NR. This is by NR. This is by NR. So P into 1 minus N by NR, which means P dV by N dt is equal to R by 1 minus N. This might be a result you've seen before already. Whenever you have PV to the power N is constant, C is given by C is equal to CV plus R by 1 minus N. And now it's easy enough. I'll just rub the rest of it and we can move from here. R by 1 minus N is equal to C minus CV, which means 1 minus N is equal to R by C minus CV, which means N is equal to 1 minus R by C minus CV, or C minus CV minus R, C minus CV minus R by C minus CV, but CV plus R is CP, so this is equal to C minus CP by C minus CV N, which gives me my answer as option 2. The next one, we want the maximum temperature of the gas. So we know nRT is equal to PV, and N and R are constant, which means T max implies that PV has to be maximum. And from the graph given, we can actually write down easily the equation for PV using y2 minus y1 is equal to m times x2 minus x1. P minus P naught is equal to 2 P naught minus P naught, which is P naught, by V naught minus 2 V naught, which is minus V naught, times V minus 2 V naught. This gives me minus V naught P plus V naught P naught is equal to P naught V minus 2 V naught P naught, or P V naught plus P naught V is equal to 3 P naught V naught. From this we get V is equal to 3 P naught V naught minus P V naught by P. And we need PV to be maximum, and we'll differentiate with respect to P because we are getting everything in terms of P. So what we get is d of PV by dV dP will be d of, this is P naught, d of P times V, which is 3 P naught V naught minus P V naught by P naught. And we have to differentiate this with respect to P. So we can do that directly. Differentiation of the first term will give us 3 P naught V naught minus P V naught by P naught, plus the derivative of the second term will give us P times, this will be simply minus P by P naught, the derivative here. and this is equal to 0. So let's see what that gives us. So this is minus V naught by P naught. We are differentiating P. So what we get is minus, so P V naught by P naught is equal to 3 P naught V naught minus P V naught by P naught, which gives us 2 P V naught is equal to 3 P naught V naught, or P is equal to 3 P naught by 2. Now what does that give us for V? We can put this back into this equation. P minus P naught is P naught by 2. P naught cancel, so we'll have minus V naught by 2 is equal to V minus 2 V naught, or V is 2 V naught by V naught by 2, or V is 3 V naught by 2. And with these two we can easily calculate the temperature, that is PV by NR, that will be 9 by 4 P naught V naught by NR, which gives me option 1. Let's look at the next one. The speed of an object is tripled when it is somewhere in the middle of simple harmonic motion. So obviously the spring is not changed, so the potential energy will stay the same, but the kinetic energy will change, right? So the potential energy will be half into m omega square. Let's assume x is equal to a sine omega t, which gives us v is equal to a omega cos omega t. Potential energy will be half m omega square x square, that is half m omega square a square sine square omega t. But x is a sine omega t is equal to 2a by 3, which means sine theta is 2 by 3, which means sine square theta is 4 by 9. So this will be 2 by 9. So potential energy is equal to 2m omega square a square by 9. Kinetic energy. Initially kinetic energy was half m the velocity squared, which is a squared omega squared cos square omega t. So sine square omega t is 4 by 9, cos square omega t will be 5 by 9, right? So this is the initial kinetic energy. What is the final kinetic energy? This multiplied by 9, because the speed is tripled. So that gives us 5m omega square a squared by 2. Right. Now this is the kinetic energy, this is the potential energy. What is their sum? M omega squared a squared times 5 by 2 plus 2 by 9, or and m omega squared a squared 49 by 18, and we know this should equal to half m omega square a dash squared, where a dash is the new amplitude, because the total energy is always half m omega square a squared. This gives me a dash is equal to 7a by 3, which gives me the answer to be option 4. Let's look at the next problem. We are given a uniform string length 20 centimeter suspended from a rigid support. Short wave pulse introduced at the lowest end. When does it reach the top? So let's assume that it is at some point at a distance x and moves the distance dx up. So at this point we can consider this part of the ring to be our system. T is upwards, mg is downwards, and what we'll get is T is equal to mg, because the rope is completely stationary. But this m is only the mass of this much rope, it's not the mass of the total rope. So that will be capital M x by L times g. This is T, right? We know what the velocity is, that is root of T by mu, which is root of mx g by L by m by L, which is root of xg. This is the velocity. This is dx by dt, and now you can easily get the answer. Dx by root x is equal to root g dt. It's at 0 at t is equal to 0, because we assume this is x is 0, tx. What we get is this is x to the power minus half, so x to the power half by half. So 2 root x is equal to root gt. There would be a plus c we don't need because we are doing definite integration. and we need to find out the time taken for it to reach. So this should be L, by the way. The final limit will reach at L. So 2 root L will be T, which means root GT. So T is equal to 2 times root of L by G is equal to 2 times root of 20 by 10 or 2 root 2 seconds. So the answer will be option 3. Let's look at the next question. There's a charge Q at the center. This is A, this is B. We are given in this region rho is equal to A by R. And what should the value of A be? So the electric field in this region is constant. So we'll calculate the field in this region. We'll take a distance up. And what will, the electric field will be E into 4 pi R square will be, because equally symmetric, epsilon. Q will be this charge plus the charge due to A by R. That will be integral of rho, which is A by R, times dV. dV will be 4 pi R square dr. From A to some value capital R, let's say, not B, some particular value capital R. So E into 4 pi R squared is equal to Q plus, this is 4 pi R dr, so 4 pi R, so 2 pi squared. 2 pi R squared minus 2 pi A squared. Right. Which means E is equal to Q minus 2 pi A squared by 4 pi R squared plus 2 pi R squared by 4 pi R squared will be, this should be A also. Yeah, so A by 2. Yeah. Now we want this thing to be independent of R, which means this term has to be 0 because we have a small r here. This is a constant. So Q should be equal to 2 pi A squared. Again, sorry, my mistake. This is A is multiplied everywhere, so this is also an A. So Q should be 2 pi A squared A, and we were asked the value of A. That will be Q by 2 pi A squared, which will give me the answer as option 1. In the next case, we are given some capacitors in a circuit. This is a battery of 8 volts. This is 4, 3 and 9. So 3 and 9 are in parallel, so they'll add up and give me 12. 12 and 4 will give me 1 by 3 is equal to 5 plus 1 by 12. This is 3 by 12 plus 1 by 12, which gives me 3 is equal to 3. So this total capacitance is 3, which is in parallel with 2. So the net capacitance will be, which means the net charge supplied by this battery will be CV, which is 40 because V is 8. Right. Now, all of this will not go into the 4 microfarad capacitance. This total as a resultant gave me 3 and this was 2. 24 will go here and 16 will go here because the charge will be proportional to the capacitance. Right. So 4 microfarad will have a total of 24 microcoulomb. Right. Then we want to find the charge on the 9 microfarad capacitor. So again we have another 24 going here, which distributes itself into this ratio. So into 3:9 or 1:3. So this will be 6 and this will be 18. So the 9 microfarad capacitor will have 18 microcoulomb. They will have opposite polarities, but the charge on the capacitor is defined as the charge on the positive plate. Right. Now we are asked the magnitude of electric field due to a point charge having this sum as the charge. So the point charge will have a value of 24 plus 18 microcoulomb or 42 microcoulomb, which means the electric field will be kq by r squared, 9 into 10 to the power 9 into 42 into 10 to the power minus 3 by 30 squared or 900. So 900 cancels with this, gives 10 to the power 7, 10 to the power minus 3 gives 10 to the power 4. So we have So this is microcoulomb. That would be millicoulomb. Microcoulomb is 10 to the power minus 6. So this gives me 10 to the power 7 and 10 to the power minus 6 gives me 10. 42 into 10 gives me 420 as the final answer. So the answer to this will be option 3. The next one is a pretty straightforward question. We know that for metals the resistance increases linearly. R is equal to R naught times 1 plus alpha delta T. But for semiconductors, the number of impurities that we put in, or the number of conduction electrons and the conduction holes, they are all exponential because the band gap is of the order of e to the power minus h mu by kt. So it is exponential, right? So for copper, it's linear because it's a metal. For undoped silicon, it will be exponential, right? For all semiconductors, it's exponential. Let's move on to the next one. So we have two wires A and B carrying the same current I. One is in the form of a square, let's say side A, and the other is in the form of a circle. So BA and BB are the values at the center. This is A, the circle, B is the square. So what is BA? That is a standard formula, mu naught I by 2R. What is BB? That we'll have to calculate. That will be 4 times what the magnetic field is due to one of them, and for one of them we can assume that there is a finite charge which makes two angles here, 45 degrees and 45 degrees, right? So what we'll get is mu naught by 4 pi A, mu naught by 4 pi A by 2 rather, because this distance is A by 2, into sine of this angle plus sine of this angle. Sine 45 plus sine 45 gives me root 2, right? So BA by B to be the I here, mu naught I will cancel, so we'll get 1 by 2R into 2 pi A by 4 root 2, or pi A by 2 root 2. But we know as well, and we know 4A is equal to 2 pi R because they are both made from the side of length L, which gives me A by R is equal to pi by 2. So we put A by R as pi by 2 L, and we get pi square by 8 root 2. Which is option 4. So the answer to this problem will be option 4. Option 16 is also pretty straightforward. The only thing for which you need higher attentivity and higher coercivity, that will be a big hysteresis loop, will be a permanent magnet. Anything else, whether it's generators, transformers or electromagnets, in which you want the magnetic field to immediately depend upon the current and the magnetic field to be shut off pretty much as soon as the current has been shut off, you need low coercivity and low retentivity for that, and that will be the second graph. It will be B for both electromagnets and transformers, so the answer will be option 4. The only thing for which we'll use A would be permanent magnets, because permanent magnets, you want that even once you remove the external current or the external magnetic field, they still have their own magnetic field and magnetization. Let's look at the next one. We are given an arc lamp requires a current of 10 amperes at 80 meters. So we directly know the resistance of the lamp. That will be 8 ohms, right? And it is connected to 20 volts 50 hertz supply of an alternating current. And what is the inductor we need so that it will give approximately the same answer? So what we need is the same amount of power supplied to this lamp so that it will glow by the same amount. That means VI should be the same, right? So in this case, what will be the net current? That will be V divided by Z, where Z is the impedance. Now 8 ohm is the resistance in this direction. In the vertical direction, we'll have omega L. And the net resistance Z squared will be 64 plus omega squared L squared. Right. And the net current or the peak current, in this case the RMS current rather, because 220 volt is the RMS voltage. So 220 by Z will be the net current, right? But there's a catch here. The net potential difference across the arc lamp will not be this value, right? It will not be the total potential difference given by 220 volts. So what we'll need is, this is the current, but the potential difference will not be 220. It will be 220 into R by Z, because if this is the inductor and this is the resistor, then this is R and this, sorry, yeah, Z. This is R and this is X. They both resultant will give Z. So if this and this will have 220 volts between them, but we want the potential between these two, right? So that will be a fraction of it, R by the, and obviously it will be R by square because they are at each other. So this gives me, this is 220 by 220 whole Z to R by Z square, and this should come out to be equal to the same value as before. Before we had VI as 80 into 10, right? So 80 into 10. Earlier this was the potential, this was the current. Now 220 by Z will be the current through it, and 220 into R by Z will be the potential across it. These two values should be the same. We can have a 10 cancel with this, and we'll have 22 into 22, this 8 will cancel, is equal to Z square. Z square will be 64 plus omega squared L squared. Now what is omega? Omega is 100 pi, because we are given mu is 50 and omega is 2 pi mu, right? So 64 plus 100 pi L whole square. And that gives us 22 into 24 will be 121 into 4, 484 is equal to 64 plus 100 pi L whole square, or 100 pi L is equal to root 420, or pi L, L is equal to root 420 by 100 pi. And if you try to calculate this value, it will come out to be approximately 0.065 henries, which means the answer to this problem will be option 4. The next, it's pretty easy. We need to arrange them in order of increasing energy. The lowest energy is for radio waves, and then you have visible light where yellow falls before blue, and finally you have X-rays. So dBAC will be the answer, which means that it is option 1. For option 19, you might be thinking, well, I know that 3 will be true, 3 is definitely true, but what about option 4? Because the ratio between U and V is also the same usually as the ratio between the height of the image. But in the case of a telescope, the final image is formed at the least distance of distinct vision, right? So this particular thing not be written tree, the image is formed at infinity, except for the special case where you make the image fall at the least distance of distinct vision. But in no case will be V 20 times U. So the answer will only be option 3. Let's look at option 20. So we are given a slit, a hole, let's say this is the hole, and a parallel beam of light is going through it. The radius of the hole is A. So if there was no diffraction, then this parallel beam of light, but because there will be diffraction, both these sides will have some divergence. And we know what this angle will be. This angle is sine inverse of lambda by A. This is a standard formula for differentiation, right? Sorry, for diffraction. My mistake, not differentiation, diffraction. Yeah. So we are told total spread is the geometrical spread and the spread due to diffraction. This length L, this distance is still A, and this L times lambda by A, right? Because lambda by A will be this angle multiplied by this distance, L lambda by A. So this is the total radius of the spot, A plus by A. This will be B. And we are, when would B minimum occur and what would B minimum be? So we'll just do dB by dA is equal to 0 to get the minimum value, which means 1 minus L lambda by A squared is equal to 0, which gives me A is root of L lambda. And if you put in this value back, L lambda by A will also be root of L lambda. So you get B is equal to 2 root L or root of 4 L lambda. So the answer to this will be option 3. Let's look at the next question. We are given radiation of wavelength lambda incident on a photocell. The fastest emitted electron has a speed v. So we know that the maximum kinetic energy, that will be half m v max squared, that will be hc by lambda minus phi, well, will be the work function, right? So from this we get, we just multiply this side by 2 by m and take the root of this whole thing. So this is Vmax. Now in the second case, Vmax, let's say Vmax dash, in case root of 2 by m times by lambda, we'll have 4 hc by 3 lambda, because lambda becomes 3 lambda by 4 now, minus 5, right? And we are asked what is this relation, its relation with respect to Vmax. So what we can see is Vmax dash by Vmax is equal to root of 2 by m times, I'll just cancel root 2 by m straight away, I won't write, because what we'll be left with is 4 hc lambda minus phi by root of hc by lambda minus phi. We can easily solve 4 hc lambda minus phi 3 phi divided by root 4 hc by 3 lambda divided by hc by lambda minus phi. We can see that this is equal to root 4 by, we take root 3 and everything else will be the same. In this, the numerator shorter than in this case, because we subtracted an extra 1 by 3 phi to make these equal. So if this value is smaller, obviously Vmax dash by Vmax will be greater than root of 4 by 3. This was just a tricky way to compare. You can think about it yourself as well. If you have 7 by 9 or 7x by 9 minus x, which would be greater, right? So this is the sort of way you start to think about this. So this will be 4 by 3 and this has the same numerator. So Vmax will be greater than root 4 by 3, which means Vmax dash is going to root Vmax, which means the answer will be option 1, right? The next one is based on radioactivity. We are given two elements A and B. Let's say they start with N1 and N2. Sorry, they start with N1 and N1 because both have the same value initially. And they have half-lives of 20 minutes and 40 minutes. So after 20 minutes, this will be A by 2. After 40 minutes, it will be A by 4. After 60 minutes, A by 8. After 80 minutes, A by 16, right? You could do this the exponential way, but it's easier to see it like this. So this is after 80 minutes. After 40 minutes, this by 2 because the half-life is 40. And after 80 minutes, this will be A by 4, rather. So it will be A by 4 after 40 minutes. After 80 minutes, this is 40 minutes. Right? So actually they both started with A. Finally this is left with A by 16 and this is left with A by 4. We are asked the ratio of the numbers that have decayed. So that will be 15 A by 16. If A by 16 and 15 A by 16 have been already decomposed, divided by, that turns out 15 by 16, 4 by 3. So it turns out to be 5 by 4 or 5 to 4. So the answer to this question will be option 4. Let's look at the next one. And in the next one, you can't actually find out what X is directly because you're not given enough information. The best thing to do is just to put in the options. Now we know that not simply cannot be true because not only takes in one value, right? So you cannot even join two not functions, right? If this is not, then that's it, you only have one value. Whereas if this is AND, say, then you can take two ANDs together, you can add them together as well, and you can add these two again and again. So if there are 4 inputs to a gate, it's either AND or NAND. It's definitely not NOT because it will always have only one gate. AND or and NAND gates can have multiple, right? So now let's look at the others. We know that it cannot be AND because there are many regions where X is true, where all of A, B, C and D are not true. For example, A is 0 for a large amount of time. A is given to be like this, whereas X is given to be like this. So X cannot be A and B and C and D because A is certainly not true, right? It can be OR, however, because in this case everyone is 0, but at every other point one of them has a value, at least 1. right? And it cannot be NAND because initially all of these are 0. So initially if it was NAND, this would have been a 1, right? So the only option left is OR, which is option 3. And if you look at the graphs closely, you will actually see that anytime A, B, C or D are true, X is true, else it is false. And throughout the whole region where it is true, either one of the 4 definitely are true. The next one is also quite a simple standard definition. In fact, in frequency modulation, you change the frequency of the carrier, but in amplitude modulation, you change the amplitude of the high frequency carrier wave in proportion to the amplitude of the audio signal. So 24 is a straightforward standard definition. The answer would be A, or 1. In 25, you are given a screw gauge, and it has a pitch of 0.5 millimeters and 50 divisions. So the least count we can get directly 0.5 divided by 50, which turns out to be 0.01 millimeters. And when scale reading is 0.5, circular scale reading is it's the 25th division, the answer should be 0.5 plus 25 into the count, 0.01, right? So that should turn out to be 0.75, right? But that is actually correct because we are also given in the question that there is a 0 error, and we need to take care of that 0 error as well. When the side 0 here should be coinciding with 0, it is actually not coinciding with 0. It is actually coinciding with -5. It's coinciding with 45 in the previous side, which is -5. So when there is nothing in between the screw gauge, the value is not 0, the value is actually -5 least counts. So for any other value, we'll have to subtract those 5 least counts as well, right? So we'll have to subtract 5 least count, and the answer will actually be 0.7 millimeters, which is option 3. If there was no 0 error, the answer would be 0.75, but you have to take care of the 0 error as well. In the next case, we are given a pipe open at both ends, has a frequency F. So if this is the pipe open at both ends, then for the fundamental frequency, which is given to be F, we need the ends to be pressure nodes, right? At the ends the pressure cannot change, so they will be pressure nodes. So this will be the fundamental frequency for a closed organ pipe, is for an open organ pipe. Now it is dipped in water so that half of it is contained inside the water. So now this is all is left, right? The rest of it is contained in water where you cannot have a wave, right? And now in this case, the fundamental frequency, you will have to have a node here, but you can have an anti-node here because this is a closed end. How the figure will be, and you can see both of them have actually the same. They're in fact exactly the same, except this part is. So the frequency will still be the same because the wavelength is still, and the speed is obviously the same. So the frequency will still be F, which means the answer. In the next case, we are given a meter that has a coil of resistance 100 ohm, and it gives a field deflection at 1 milliampere, and we wanted 10 amp deflection. So what we do is we attach a shunt resistance in parallel. So this is 100 ohm. Let's take it to be capital R. This is a small r, and we are sending current here. And what we want is, we want to be able to measure a maximum current of 10 ampere. But this can only measure a maximum current of 1 milliampere. Well, so there's a simple solution. We attach a shunt such that most of the current goes to this shunt and only 1 milliampere goes here. So when you have 10 ampere going here, you should have 1 milliampere coming out here. Right. So 1 milliampere, that is 1 by 1000, should be equal to 10 ampere times R by R plus 100. Right. Which gives me R by R plus 100 is equal to the power minus. Right. Now we already know that R plus 100 is very, very small. R has to be very small as well. Assume this to be R by 100, which gives me R is equal to 100 into 10 to the power minus 4 or 10 to the power minus 2 or 0.01. So the answer will be option 1. Let's look at this case. We are given prism, the incidence angle, one of the refraction angles, and the emergent angle. Because incident and emergent, this is not the case minimum, this is not the symmetric case where this is parallel to the y-axis, parallel to the x-axis. This is R1, R2. So what we are getting is I is 35 degrees, E is 79 degrees, and there is a deviation of 40 degrees. And we know what the deviation is. It's I minus R1 in the first case plus E minus R2 in the second case. So this gives me 40 is equal to 35 minus R1 plus 79 minus R2, which gives me R1 plus R2 is equal to 74 degrees. If we come quarter line, this is 90, this is 90. So this angle plus A is equal to 180, but this plus R1 plus R2 is also 180, is equal to R1 plus R degree. We are seeing actually two exceptions in this question. Not only is it not the minimum deviation, but this angle is also not small, it's quite large. We are asked what value is the close to the maximum possible value of refractive index. Right, that's quite easy. The maximum possible value of refractive index should make sure that there is no total internal reflection. Right, then at no other value will there be any total internal reflection. Right, so because it's the maximum case, we'll assume that I is the maximum, which is 90 degrees. If there is an incident ray at 90 degrees, it comes out like this and it emerges like this. If that is just totally internally reflecting, then no ray will really be totally internally reflecting, right? If we can make sure even this ray is not totally internally reflected, then no ray will be, which means that the ray will actually emerge outside. So this is the case we have to consider. Now this is the symmetric case, right? This is A by 2 now, this is R. And what we'll get is 1 into sine 90 is equal to mu into sine R. But because this is the symmetric case where R and R dash are the same, R can be written as A by 2, which we could put in the previous case. So that means mu sine A by 2 is equal to 1. A is 74, what is A by 2? And remarkably, it comes out to a nice value, 37 degrees, whose values you already know. So sine of A by 2 will be 3 by 5. So 3 mu by 5 is equal to 1, which means mu is equal to 5 by 3, which is 1.666 dot dot dot. This is the maximum possible value for refractivity, for which there is no total interreflection. Right. So the closest value is obviously 1.7, which means the answer is option 3. The next is also pretty standard fashion. The standard P injection diode. So there will be a simple that itself gives you option 1 because no other option is a simple diode, because it doesn't go back. The Zener diode is meant to break down region. So the normal diode is not meant to be operated there. Don't show those characteristics as in the graph. We actually show these breakdown characteristics. C is also the standard graph for solar cell that you find in your NCERT textbooks, and from that automatically you can get the answer option 1. And D is also actually a standard result, though if you want I can derive it. Beta is defined as IC by IB, and alpha is defined as IC by IE, And we also know that IE is the total current is equal to IB plus IC, right? So from this we can get IC by IE plus IB by IE is equal to 1, right? IC by IE is alpha, plus we need IB by IE, which will be 1. Now we can put in the value of IC here, and what we'll get is beta is equal to IE minus IB by IB is equal to IE by IB. Yeah. Good look, is it? E via yeah. E via. Yeah. Good look, is it? Regular problem. He's yeah. For 11 the problem one. Now we must do yeah. Every yeah. So half flat. See yeah. Every yeah. Now good look, is it? E yeah. Every yeah. So E yeah. Every yeah. Right, gives it more. Yeah, this yeah. So E yeah, we look easy. Yeah, we look at the E yeah. I don't solve now. E yeah, every yeah. Yeah. So yeah, it's a flat now. IB will be the inverse of this. This is 1 minus alpha, so 1 by 1 minus alpha minus 1, which means 1 plus beta is equal to 1 minus alpha, or 1 minus alpha is equal to 1 by 1 plus beta, which gives me alpha is equal to beta by 1 plus beta. Or this is a standard result, you probably know this already, which means the answer is option C. This completes the 2016 JEE Mains Physics paper. Thank you.